Boys and girls, here's the first example about riders. Now, the most important thing is how do we approach questions based on riders. Now, we are given a diagram with information. We firstly start by reading the information about the diagram. And then if something is not indicated on the diagram but mentioned on the statement, please, or on the information, please transfer that information into a diagram. For example, we are given BC is parallel to DF. If it is not indicated that these lines are parallel, please indicate it. That's how we approach this. Then another thing, after transferring information into a diagram, then we don't go on and satisfy a question by a question from the diagram to get answers. No, we're going to apply what you know. You learned all 7 theorems and definitions. What you're going to do is to indicate angles that are equal there or sides that are equal, anything that you know, because you know all 7 theorems. Now, when you look at this diagram, you're going to approach those questions like this. When you look at this diagram, they said this line is a tangent. Immediately when they mention a tangent, you must think about tan-cot theorem and other things about tangent. If there is a line from center and it is connected with tangent, then you're going to use that knowledge. But now, if you check here, there's no line from the center. We are not given the center. Now, let's indicate angles that are equal without satisfying these questions. No, we indicate doing rough work. Now, we are given a tangent. Which angle can be indicated the same as E3? When we use the knowledge of tangent, this is a tangent and this is a chord. Now, the angle in the alternate segment, these two angles are equal by tan-cot theorem. Again, this one, x, is equal to that other angle. But these lines are parallel, don't forget. And then by alternating angles, these two angles are equal. Then we're going to indicate these two angles equal by alternating angles. Now, by tan-cot theorem, or by alternating angles, these two, we can indicate them equal. So far, we indicated 4 angles equal. Other angles that are equal, if you check, C2 is in the same segment as A1. Then we can indicate A1 the same as C2. Right. Let's check other angles that are equal. Right, now, have a look at A2. A2 is equal to B2. And many angles are equal there. Right, now, we can also indicate which angle equal to B1, angles in the same segment. This one can be highlighted in blue, this one in blue. We are doing rough work. We are not answering question. Now, again, this angle, we can highlight it in green. This angle is equal to that angle. Angles in the same segment. Now, after doing rough work, if you think it is enough about rough work, then now you're going to look at your question and check if you're not going to see answers from your rough work. Now, they said indicate, find 5 angles equal to x. That is the first question. We were given that angle DEB is x. Now, if you check, many angles are indicated the same as this one. How many are there? Let's count. 1, 2, 3, 4, 5. Now, they want those angles. Then what you're going to do is to present step by step by giving reasons why you indicated that this angle is the same as that, tan-cot theorem. Why this angle is equal to that by alternating angles mention parallel lines. Why B2 is indicated the same as A2. Now, let me present it for you so that you understand exactly how you're going to present. Right. Angle BED is indicated the same as angle C2, equal to angle C2. What is the reason? Tan-Cot theorem. Tan-Cot theorem. Therefore, angle C2 is equal to X. Right. Again, BED. BED is equal to angle F or angle B2. Angle B2. What is the reason? Alternating angles, then mention parallel line. BC is parallel to DF. Therefore, angle B2 is equal to X. But angle B2 is equal to angle A2. What is the reason? Angles in the same segment. Angles in the same segment. Therefore, angle A2 is also equal to X. Right. Now, we are left with this one. But we mentioned that. But angle C2 is equal to angle A1. What is the reason? C2 is equal to angle A1. Angles in the same segment. Angles in the same segment. Remember, we already mentioned that C2 is equal to X. Then we can replace C2 by X. Therefore, angle A1 is also equal to X. Right. This angle E3 is also equal to X. It's one of these by direct reason. Angle E3 is equal to angle B2. What is the reason? E3, here is E3. E3 is equal to B2. What is the reason? Tan-Cot theorem. Or you can go by direct reason. E3 is equal to C2. Alternating angles, parallel lines. Therefore, angle E3 is also equal to X because we mentioned that B2 is equal to X. Here is it. We mentioned that B2 is equal to X. Then we can replace B2 by X. Now, let's count those angles. 1, 2, 3, 4, 5. Then we are done with this. The next question says, prove that EC is a tangent to circle ADC. EC is a tangent to circle ADC. ADC. There is imaginary circle around here passing through ADC. Now we're going to prove that EC is a tangent. Right, the question is, how do we prove that a line is a tangent? Now, this is a simple thing. Two things are required to conclude that a line is a tangent. If a line is drawn from the center of a circle and then in contact with another line, a radius in connection with another line, then they form 90. If angle OAB is 90, then we can conclude by saying, therefore, AB is a tangent. When we see this situation, because it is not always the case that a line will be from the center and in connection with another line at point of contact. Radius in connection with another line at point of contact form 90. Let's say it forms 80 there. Then this AB is not a tangent. Now, what is the reason? How do we reason here? The reason is converse. Converse Tarncourt. Converse radius perpendicular to tangent. Converse radius perpendicular to tangent. Because we know that the radius in connection with tangent form 90. But we were not given that this angle is 90. Now we can use it to conclude that AB is a tangent because this angle OAB is 90. Clear? That is the first thing. Second thing, if Tarncourt theorem is satisfied, if y is equal to x, if there is a circle around here passing through here and they want us to prove that AB is a tangent to the circle passing through these 3 points. Now, if these two angles are equal, therefore we conclude by saying AB is a tangent. Because Tarncourt theorem is satisfied. Then now, what is the reason? Remember, the primary goal is to prove that AB is a tangent. Now, the secondary goal is this, that we use to conclude that a line is a tangent. If y is equal to x, therefore AB is a tangent. What is the reason? Converse Tarncourt theorem. Because Tarncourt theorem is satisfied. That's what is only needed to prove that a line is a tangent. Right, but if you check this question, we don't have the center here in that circle. We don't have the center in that circle. Therefore, we're not going to think about this one. We're not going to think about this one. We're going to check if this one is satisfied. Now, let's check. From this diagram, we can see Tarncourt theorem satisfied from the rough work. What we're going to say is that C2, angle C2 is equal to angle A2. What is the reason? Each equal to x, because from the first question, we proved that each one is x. Each equal to x. Now, if these two angles are equal, Tarncourt theorem is satisfied. Now, we conclude by saying, therefore, EC is a tangent. Tangent to a circle ADC. What is the reason? Converse Tarncourt theorem. We are done.